Question number 46. Consider the sequence of reaction. So benzene reacts with this alkene in presence of HF at 0 degrees C. It is going to lead to the formation of cumene. So this is our structure A. Now A is allowed to react with hot acidified KMnO4. So this hot acidified KMnO4 is going to convert it into benzoic acid. Okay, so this is our structure B. Now this benzoic acid is allowed to react with PCl5. So this PCl5 is going to lead to conversion of the acid into acyl chloride. Okay, so this is our structure C. And when it is reacted with N3 minus in basic medium, it is going to convert this. The N3 minus will replace the Cl minus from the system. So we're going to have this structure. So when it is allowed to undergo heating, it will undergo nitrogen rearrangement. We'll have the formation of isocyanate, and this upon further hydrolysis is going to give us aniline. So we have to comment on the end product of this reaction. So we have to mark PHNH2 as the correct answer to our question, which is given in option 3. Let us look at the next question. Question 47. The end product of the given reaction sequences. So we have been given an ester and it is allowed to react with ethoxide ion. So students, we can rule out the possibility of trans esterification as the leaving group will be the same as the incoming nucleophile. So we need not worry about the attack of the ethoxide ion on this carbonyl carbon. So the next, it will try and extract this acidic hydrogen. So we have the acidic hydrogen extracted, which will lead to the generation of a nucleophile. And it is going to attack on another molecule present. And it will make this OAT group leave. So this is going to give us a beta keto ester. Okay. So now it is further given to us that it is allowed to react with ETONA and further with CH3I. So students, we have an active methylene group over here now. So the ETONA is going to extract the proton present over here. It is going to lead to the formation of nucleophile. And this will attack on the CH3I and make this iodide ion leave. So on simplification, this is going to form this species. And when it is further subjected to hydrolysis and heat, so upon hydrolysis, this will convert into acid. And upon heating, since it is a beta keto acid, the beta keto acid will undergo decarboxylation to give us a ketone. So we'll have the formation of butanone in this case. So students, we have to mark option 4 as the correct answer to our question. Let us look at question number 48. Consider the below sequence of reaction. So in the first step, the bridgehead amine compound is allowed to react with CH3I in excess, and it is further allowed to react with Ag2O moist. So students, the examiner is interested in Hoffman's elimination. Okay. So in the first step, the lone pairs over nitrogen are going to attack on the CH3I and the nitrogen will get methylated exhaustively. So we are going to have the formation of this species. Okay. Now, when the species is heated with Ag2O moist, so we'll have the formation of a double bond. So this bond will shift and this will lead to the ring opening in this case. So we'll have the formation of the following species. And the positive charge on nitrogen shall be compensated with the bond pair which is shifted on nitrogen. Okay. Now it is given to us that this is further allowed to react with CH3I. So it is going to get further methylated again, turning it into a quaternary ammonium salt. So we are going to have NMe3. Again, the plus charge will be there on nitrogen. And now on further heating with Ag2O moist, it will lead to the formation of benzene. The H present here shall get extracted and the bond pair will convert into the lone pairs on nitrogen. So this will lead to the formation of an aromatic compound which is benzene. So students, we can see that the major product of the given reaction sequence is option 2. So we have to mark option 2 as the correct answer to our question. Let us look at question number 49 now. Different organic reactions with their product are given below. Select the incorrect reaction. So let us look at the first reaction now. In the first reaction we have PHLi. So PHLi is going to give us pH minus, which is a strong base. The strong base is capable of alpha elimination. So what it will do is it will go and extract this hydrogen and simultaneously this Cl minus will also leave. So in order to satisfy the valency of this electron deficient carbon, this will shift over here and will get the formation of an alkyne. So students, this reaction is correct. Let us look at the second reaction. We have an amine reacting with NaNO2HCl. So this NaNO2HCl is going to attack on the amine and convert it into N2 plus, which is a good leaving group. It will leave and then the H2O will attack on the carbocation and it will lead to the formation of an alcohol. The statement is correct. Let us look at the third option now. In the third option, the examiner is interested in Hofmann bromamide degradation. So what it will do is it will convert the amide into an amine. So this part of the reaction is correctly represented. But what happens is Br2 in NaOH leads to formation of NaOBr, which is a strong oxidizing agent. So that strong oxidizing agent will lead to the oxidation of this alcohol into aldehyde. But in the question, it is given to us that this alcohol is reduced to a methyl group. So this part is incorrect. It is going to be converted into CHO and not CH3. So reaction 2 is incorrect. Let us look at the reaction 4 now. So we have aniline reacting with bromine water at low temperatures. So students, aniline is very activated compound towards electrophilic substitution reaction, and when bromination takes place, it forms a tribromo derivative. So students, the fourth reaction is also correctly represented. So in the question, since we have to select the incorrect reaction, we have to mark reaction number 2 as the correct answer to our question. Let us look at the next question now, question number 50. So we have been given a reaction in which Friedel-Crafts alkylation takes place. So it is going to lead to the formation of a tertiary butyl cation, and that tertiary butyl cation is going to attack on the benzene ring and make it undergo electrophilic substitution reaction. So we have product X, which is represented by this structure. Okay. So now the examiner is interested in knowing that out of the given 4 reactions, which of them are going to produce this as the major product. So let us look at the first option now. So this AlCl3 will extract this chlorine. So the chlorine will leave, which will lead to the formation of an acyl carbocation. Now when this acyl carbocation is formed, we can see that there can be evolution of CO as well, as the tertiary butyl carbocation left behind is very, very stable. So the first intermediate which we had got in this case was this. and this will again undergo loss of a CO molecule to form a tertiary butyl carbocation. Okay, and now this tertiary butyl carbocation will attack the benzene ring and lead to the formation of X. So reaction first will form X as the major product. So this should be the answer to our question. Let us look at option 2 now. So in option 2 we have again alkyl chloride and then AlCl3. So this AlCl3 is going to extract this chlorine. It is going to lead to the formation of a carbocation here. And then this electrophile which is generated shall attack the benzene ring and lead to the formation of this species. So reaction 2 is not going to form X. Let us look at the third option now. AlCl3. AlCl3 can attack anhydrides as well, and it will make this group leave, which will lead to the formation of an acyl carbocation, and it will lead to acylation. So we'll have PH COCH3 formed. This is also clearly not X. Let us look at the fourth option now. So this AlCl3 again, we have an anhydride, and this AlCl3 will make this group leave, which will lead to the formation of this electrophile, which shall attack the benzene ring and lead to acylation again. Okay. The CO cannot leave in this case because the carbocation formed is not as stable as compared to the tertiary one which was created before. So the CO will leave in this case and it will not leave in this case. So this reaction, it will also not lead to the formation of X. So students, as we had already seen before, we have to mark option 1 as the correct answer to our question.